picking up where we left off, we're going to continue talking about research design. So we ended the last lecture talking about good data and bad data. And we're going to pick up with that here to talk about how we can get better data. Now, what do we mean by better data? We do not necessarily mean data that supports our hypothesis. We mean data that is more representative of the population we're trying to measure. In all of our studies, we deal with samples of populations. The population is the whole group of people or animals or individuals in the world. So if we are doing a study on females between the age of 10 and 18, the population would be every female in the world between the age of 10 and 18. And our sample would be the group of females that we are studying between the ages of 10 and 18. So we're always trying to make sure that our samples are most representative of the population at large and that they are not biased, that there's not something that's different about our sample that could impact how we interpret our results. And there's a few ways that we can do this. One is randomization. So for an observational study, if you were doing a survey, selecting respondents randomly as opposed to standing outside of an individual store. This would be one way to have a more random sample. We like random. In an experimental study, this could be assigning subjects randomly to a trial and control group. If we are testing an intervention or a drug, we would like to know that if we find a significant difference in the group after the intervention, that it's due to the intervention, as opposed to some pre-existing difference between the two groups. The next way that we can get better data is placebos. This is generally part of a process called blinding. When we deal with placebos, we give the control group something such as a sugar pill to make them not know whether or not they've been treated. Again, talking what we talked about in the last time, that people's behavior and people's expectations can impact an outcome. So if we keep the behavior, if we keep the intervention the same, if we give some people a sugar pill so that they don't know whether to expect that they've gotten the real drug or not, then we can be a bit more confident in our outcome. And this is one example of blinding. Double blinding is when both the researchers and the participants don't know if they've been given a real intervention, a real drug. And this is important because just like human participants can impact outcomes based on their expectations, human researchers can impact outcomes based on if they know that a participant has been given the real thing, they might act differently towards the participant than somebody that they know has been given a placebo. And so in these cases, for double blinding, researchers and participants don't know if they've been given a placebo or a real intervention. Of course, this is taken note of elsewhere so that we can actually do the comparisons, but during the course of the study, the researchers don't know what condition people are in. A little bit more about the placebo effect. So sometimes people feel better just taking something as opposed to taking nothing. So if you gave them a placebo, a sugar pill, and they think that it's going to work, then they might actually see a difference in their symptoms. And one very interesting example is the video that is linked here, which is a 5-6 minute video on YouTube that you should watch, and it gives the example of an experimental knee surgery. Some people received a fake surgery and yet their knee pain improved. This is a good example of a placebo control where the real condition would have been real knee surgery. Double-blind studies, a little more detail. So in these studies, neither the experimenters nor the participants know whether they are receiving the treatment or the placebo. That way, the experimenter cannot accidentally reveal that they're administering a placebo or not, and they cannot subconsciously impact the outcome based on behaving differently towards people who have received the placebo versus the real condition. Data analysts, as I said, will know who has received which so that they can actually compare things, but for the duration of the study, the experimenters do not know. The next big concept that we're going to talk about has to do with how we interpret our data, and it is the null hypothesis. We are going to go into a lot more depth on this in the statistics module. We provide evidence for our hypotheses by disproving the null hypothesis. So, for example, generally a null hypothesis could be that there is no statistically significant association between two variables. So perhaps, as an example, people who spend an hour a day on TikTok will score the same on standardized tests as those who do not. Whereas our alternative hypothesis, the one that we're more interested in, is that there is a statistically significant association between two variables. So in our TikTok example, our alternative hypothesis could be that people who spend an hour a day on TikTok will have lower test scores than those who do not. And this might seem a bit silly to set up these two hypotheses when really our question's just, does time spent on TikTok impact test scores? But this comes down to what we can actually prove statistically. The fact that you can't disprove a negative and that you can't prove something if you're only looking at a sample of the data and not everything. We're only ever dealing with samples, so we can provide evidence to support our hypotheses, but we can never prove that our hypothesized association exists. We can disprove the lack of association, though. And if this is a bit confusing, don't worry, we'll go into a lot more detail on it, just to orient you to our thought pattern, what we prove and what we disprove, and how we go about setting up our statistical analyses. Ethics in research. Again, we'll go into a lot more detail on this. When doing research on humans, such as testing a new drug or a psychological principle, it's important that we follow certain standards of ethics to be eligible for government funding and to be approved by the FDA. There are certain standards that we have to apply regardless of where our funding comes from, and people can be in legal trouble if they do not abide by these ethical codes. These codes, of course, also exist for animal research, but our focus here is human research. These standards were developed because of many historical examples, many studies in history that have disregarded human rights or exploited unprotected groups of people. So these examples can be disturbing, just a warning. There are countless examples of unethical studies that have been done in the past. The Tuskegee syphilis study is a very well-known one, and in this case, the researchers denied Black men with syphilis treatment so that their condition could be studied, so that they could study the course of the disease. Given that there was treatment available and they did not give this treatment to the men, this is a highly unethical study. The Stanford prison experiment is another interesting one and another unethical experiment where they were trying to see whether people were, generally they were trying to see whether people were innately, could be innately bad. This was coming off of the off of World War II and the Nazis and the argument that people were just going along with what they were told to do. So in the Stanford prison experiment, they recreated a prison environment with students who were randomly assigned to be prisoners or guards. And the study had to be terminated early because randomly assigning people to these groups, the guards pretty quickly turned sadistic, and the prisoners pretty quickly started to exhibit signs of real mental distress, and so the experiment had to be stopped. Of course, every single Nazi experiment done on concentration camp prisoners was highly unethical and disturbing. And the Willowbrook hepatitis studies deliberately infected intellectually disabled children with hepatitis in order to develop a vaccine. So in all cases of these, there was disregard for human rights. There was, in some cases, lack of protections for people who were more vulnerable, whether it's children, people who are sick, people who are prisoners, people who are intellectually disabled. In all cases, these can be protected groups. So these are all very unethical studies that we all study so that we know what not to do. Autonomy. This is one important tenet of research ethics, human research ethics. Autonomy is the right a person has to their own body and the ability to make choices. Research on human subjects should always respect autonomy. This means protecting privacy as much as possible, allowing the participants to leave the study at any time, and informing the participants of any risks that they might expose themselves to by participating in the study. Some individuals have limited autonomy, including children, prisoners, people with terminal illnesses, and people with mental disabilities, which are all examples that you saw on the previous page. People who have limited autonomy, there's a whole host of other regulations that we need to follow to make sure that we are not taking advantage of that and that we are respecting their autonomy, whether it's having a representative to advocate for them. These are considered special categories of potential study participants. Informed consent. Researching human subjects requires participants to sign a consent form. So consent is continuous. It is revocable at any time. At any time, someone can say that they no longer want to participate in a study. And if they say that, they have revoked their consent and you cannot continue the study with them. Consent means that somebody is fully informed of the risks, the benefits, and any alternatives if you're testing a treatment, any alternative treatments that are possible and are out there. It is not coerced. Someone has to freely consent to participate in the study. It's specific to a certain situation. So you detail exactly what your study is going to do, and people consent to that exact study and to the activities that are detailed in your consent. And you cannot place undue influence on people. Often there's a small amount of money given to research subjects to compensate them for their time, but this can't be too large because then it's seen as creating undue influence and making somebody, bribing somebody, making it hard for them to say no, whether or not they actually want to participate. Justice. In study ethics, this means that certain groups of people shouldn't bear undue responsibility to participate in research simply because it's more convenient. So again, talking about vulnerable populations, prisoners, orphans, and homeless people were used in many prior experiments because they had limited autonomy and no support systems. This is not respecting justice. These people also have limited access to healthcare, so they couldn't enjoy the benefits of research. So broadly what justice means is that one group of people shouldn't have to participate in studies for another group of people to benefit. We should all benefit from research. And if someone stands no chance of benefiting from some research, they should not be in the study. Minimizing harm, maximizing benefits. Research on human subjects should involve as little risk as possible. There's often some risk, which you need to disclose to your subjects. Steps should be taken to prevent injury, to limit any pain, to prevent long-lasting side effects, to prevent psychological trauma, and to prevent any breaches of privacy. Example 1, you believe that you've developed the cure to senioritis. In preliminary tests in guinea pigs, a few of them began uncontrollably writing graduation speeches. You decide not to list this side effect in your consent form because it was so rare. Is this ethical or not? The answer is no, you have not given informed consent. You should be listing any side effects that somebody might experience, whether it's uncontrollably writing graduation speeches or a lot of those side effects that you often hear said very quickly in pharmaceutical ads. Example 2, you are a psychology professor. You develop a study to examine the link between electric shocks and screen volume. You tell your students that participation in your study is worth 50% of their grade. Is this an ethical study? Of course not. You cannot You cannot have undue influence on the study subjects. So by telling somebody that this is worth 50% of their grade, of course, that's a huge influence on whether they decide to participate in the study or not. It also has no benefit to anybody. Why on earth does it matter what the association is between electric shocks and screen volume? So there should be some benefit to the students from the results of your study. Can't see any real benefit here. So no, this is not an ethical study. Example 3, you want to test an experimental tuberculosis cure on Muppets. So you approach Kermit and Bob Cratchit, Kermit/Bob Cratchit, and ask if Tiny Tim would like to participate in research. In exchange, you will provide food and housing for the family. Is this an ethical experiment? No. This is an example of undue influence. By providing food and housing for the family, you're not really giving them the choice of whether or not they want to participate in the study.